Hi, this cat is called persistent bugger. What do we have to do? Well, we have to write a function that takes a number as an input, and we have to return the number of times that we must multiply the digits in the argument until we reach one single digit. Take this for example, when we get a 4, we can return 0 immediately because it is already a single digit. On the other hand, when we get 39, then we have to do the following. We have to multiply 3 with 9, which leaves us with 27. And then we have to multiply 2 with 7, which leaves us with 14. And finally, we have to multiply 1 with 4, which leaves us with the single digit 4. That takes 3 iterations, hence we have to return 3. How to go about this? Before we start, what I want to do is to convert this integer that we have here as an argument to a list of integers. Let's start with a single digit, by the way. So let's start with creating a variable. Working underscore list is equal to, and we'll use list comprehension, integer for integer in n. This won't work, but I'll showcase you why. Print working list. Type error, the integer object is not iterable. Yeah, that's true. So let's convert it to a string type and put in the argument. And yeah, when we execute this, we get 4. But these quotation marks reveal that we are dealing with a string type. So let's convert it back to an integer right away. And when we have 39, we get a list of integers. Yeah. And let's use a condition. The length of the working list should be equal to 1. And then we can return 0 right away. In this case, it is false, but when we have 4, it will return true. Yeah. So if this condition is met, we can return 0 right away. Yeah, 0. When we have 39, nothing will be returned. So let's print the working list again. And how do we actually get the product? 27 in a very easy way. Well, for that, we can use the NumPy library and use the product method, numpy.method. And again, it takes the working list as an argument. Well, of course, we have to use product, not method. Yeah, 27. But this is only one iteration. And what I want to have is, again, a list with integers of 2 and 7 to perform the same calculation. How do we do that? Let's say the following, that the working list should be equal to the product. But then, after the first iteration, we should convert it back to a list. Again, we use list comprehension, so integer for integer in the string of working list, and convert this integer back to an integer type, of course. Yeah, so let's print the working list here, 2 and 7, and when we do the same, let's imitate that we do an extra iteration by hand. When we print the working list, we get 1 and 4, 1 and 4. So this is the tactic that we have to use, but this is kind of a stupid way. How can we automate this? Well, with a while loop. So let's say that we have a condition. Well, the length of the working list is more than 1. Then we perform this action here. Let's print the working list. Of course, we need a colon here. Yeah. So first we get 27. Then we get 1 and 4. And the third iteration, we have a single digit 4. And that is the sign that the loop has to stop. But we have to return kind of a counter. So let's create a counter here. It's equal to 0. And what we have to do is to add up 1 with the counter every iteration. So the counter should be equal to the counter plus 1. Or shorthanded plus equals 1. And let's print the counter next to the working list. Yeah, 3 iterations it takes before we get to a single digit. And what we basically have to do is to only return the counter outside the while loop. And that will probably work out. 3. How about this one? 999 should return 4. And that works like a charm. Let's test it out. Attempt. And there we go. Passed all the tests. I thank you for watching and hope to see you in another video. Ciao.